Hey guys, Elmer the exponential elephant here, talking to you about division properties of exponents. Now here's a question. What do you call an elephant with a really long nose? A smelephant!
First thing we're going to do is review exponents. So when you have something raised to a power, that something is called your base, the power is called your exponent. And the exponent just tells you how many times to multiply the base by itself. So if you have 4 to the third power, that's telling you to multiply the base by itself 3 times. Multiplying 4 by itself 3 times. That's how you get 64. Next thing we're going to review, scientific notation. That's a method of writing really large and really small numbers. Scientific notation is written in the form a times 10 to the nth power, where a has to be between 1 and 10. It can equal 1, but it cannot equal 10. And n has to be an integer. If you have a really big number that you're converting into scientific notation, like a million, then n is going to be a positive integer. If you have a really small number, like close to 0, like 0.000001, that means that n is going to be a negative integer. We're also going to review multiplying powers with the same base. Anytime you multiply two numbers or variables with the same base that are raised to an exponent, what you're going to do is you're going to add those exponents together, okay? Even if you don't even see an exponent, that means it's an exponent of 1. So if you're multiplying like bases, you're going to add the exponents together. Here, we're going to review raising a power to a power. So to raise a power to a power, you're going to multiply the exponents. So if you have something, a base, raised to a power, and that whole quantity is being raised to a power, then what you're going to do is you're going to multiply those two exponents together. Now, this is new for today. So dividing exponents with the same base. So to divide powers with the same base, you're going to subtract the exponents. Last time we said if we're multiplying like bases, we add the exponents. So here, if we're dividing like bases, we subtract the exponents. It only makes sense.
Why did the elephants quit their job at the circus? Because they were working for peanuts! Example time.
Now example 1 says copy and complete each equation. So we have 5 to the 9th power over 5 to the 2nd power equals 5 to the what power? So again, we have like bases. We have 5 here and 5 here. And since we're dividing these like bases, what we're going to do with the exponents is we subtract those two. So what is 9 minus 2? That's 7. So 5 to the 9th divided by 5 to the 2nd power is going to equal 5 to the 7th power. Here, we have x to the negative first over x to the negative fifth equals x to the what? So again, like bases, x and x. Since we're dividing like bases, we subtract the exponents to simplify this. So what is negative 1 minus negative 5? Well, again, negative 1 minus negative 5 is the same as negative 1 plus positive 5, which is going to be 4. So your answer is x to the 4th power. Part C, we're going to simplify this. What we need to do first, you see how in our numerator and denominator, we have not just one base, we have multiple bases, but you can see that they're actually the same. Here we have 7 and 7, here we have 7 and 7. Well, why don't we simplify the numerator and denominator first, and then we can divide. So let's do that. In our numerator, if we multiply like bases, what we can do, 7 to the 4th power times 7 to the 5th power. When you multiply like bases, you add the exponents together. So in the numerator, it becomes 7 to the 9th power. In our denominator, 7 to the 6th times 7 to the 2nd equals 7 to the 8th power when you add those two exponents together. Now, we have simplified this a little bit, so it's much easier to get to our final answer. So what is 7 to the 9th divided by 7 to the 8th? Well, since you're dividing like bases, you subtract the exponents. So what is 9 minus 8? That's going to be 1. So here, 7 to the 9th divided by 7 to the 8th is going to be 7 to the 1st. And then for part D, we again have the same thing over here, except it's not 7, it's a this time. So we need to simplify our numerator, simplify our denominator, and then we can divide. Let's go ahead and do that. In our numerator, a to the negative 2nd times a to the 3rd. Since you're multiplying like bases, you add these exponents together. So what's negative 2 plus 3? That's 1. So in our numerator, we have a to the 1st power. In our denominator, a to the 9th times a to the negative 7th. You add those two exponents together because you have like bases. So 9 plus negative 7 is 2. Now here we can, since we have like bases, and we're dividing, we're going to subtract these exponents. So what's 1 minus 2? That's negative 1. So your answer should be a to the negative 1st power.
You hear what's big in Africa right now? Elephants! You try.
Doing the same thing. We have negative 2 to the 4th power over negative 2 to the 7th power equals negative 2 to the what? Well, we have like bases, so since we're dividing these two like bases, we want to subtract our exponents. So what is 4 minus 7? That's going to be negative 3. So negative 2 to the 4th over negative 2 to the 7th equals negative 2 to the negative 3rd power. Here we have y to the 5th over y to the negative 5th equals y to the what? Well, since you are dividing like bases, you subtract the exponents. Now, please don't just rush and put 0 here. You got to actually do it. What is 5 minus negative 5? That's the same thing as 5 plus positive 5, which is 10. So this becomes y to the 10th power. Part C, we're doing the same thing. Here we need to simplify the numerator and denominator first. So in order to simplify the numerator, we multiply like bases. That means we add the exponents together. When we multiply like bases, we add the exponents together. So 8 to the negative 7th times 8 to the 3rd, we add negative 7 and 3, and we end up getting 8 to the negative 4th in our numerator. In our denominator, 8 to the 8th times 8 to the negative 2nd, because these are like bases, when we multiply, we add the exponents. So 8 plus negative 2 is 6. Now here, we're dividing like bases, which means we subtract the exponents. So what's negative 4 minus 6? That's going to actually be negative 10. So our final answer should be 8 to the negative 10th power. Here, doing the same thing that we did in part C. So w to the 10th times w, we need to simplify our numerator and denominator first. W to the 10th times w, well, w is w to the 1st, right? So when we multiply like bases, we add the exponents together. So what's 10 plus 1? That's going to be 11. So we get w to the 11th over here. And then in our denominator, w to the 20th times w to the negative 5th, we multiply like bases. That means we add these exponents together. So 20 plus negative 5 is going to be 15. Now when we are dividing like bases, we subtract the exponent. So what's 11 minus 15? That's going to be negative 4. So our final answer should be w to the negative 4th power. Example 2, doing the same thing. We have 9 to the 5th over 9 to the 2nd. The only difference here is now we are simplifying each expression. We're not going to just leave it with an exponent at the end. So here we have 9 to the 5th over 9 to the 2nd. When you divide like bases, you subtract the exponents. So what's 5 minus 2? That's going to be 3. So our answer is going to be 9 to the 3rd. But you're not going to leave it like that, because we know how to simplify 9 to the 3rd. 9 to the 3rd is 9 times 9 times 9, which we now know is 729. For part B, we have x to the 3rd over x to the 7th. When you divide like bases, you need to subtract the exponents. So here, when we subtract these two exponents, 3 minus 7, that's going to give you negative 4. So we get x to the negative 4th. But remember, when we simplify, we don't want to leave a negative exponent in our answer. So what we do instead is we convert it to a positive exponent. How do we change this to a positive exponent? Well, you take it and you move it to the opposite side of the fraction bar. So we're going to take x to the negative 4th, move it to the denominator, so it's going to be 1 over x to the positive 4th. Now for part C, you might right away be like, oh, we did this last time, right? We just have to simplify the numerator and denominator first. Well, no, right? Because we have an m and an n. And an m and an n. That means that you cannot multiply these two together and combine them into one thing, right? Because they're different bases. So what we do instead is we divide each variable separately. So we have m to the 3rd over m to the negative 1st. When you divide like bases, you subtract the exponent. So what's 3 minus negative 1? That's going to be the same thing as 3 plus positive 1, which is 4. So this becomes m to the 4th. Over here, n to the 2nd over n to the 3rd. When you divide like bases, you subtract the exponent. So what's 2 minus 3? That's negative 1. So we end up getting m to the 4th, n to the negative 1st. Now what you do is you simplify, because we can't have a negative exponent in our answer. We need to take this n to the negative 1st and move it to the denominator, where it becomes n to the positive 1st, or just n, and you're done. Part D. Doing the same thing that we did over here in part C, we're going to take each of these separately. We're going to divide 12 and 4 first. So what's 12 divided by 4? That's going to be 3. So we're going to have 3 in our answer. Next, a to the negative 1st over a to the 5th. When you divide like bases, you subtract the exponents. What's negative 1 minus 5? That's going to be negative 6. So we have a to the negative 6. We have b to the 6th over b to the negative 1st. Subtract the exponents. What's 6 minus negative 1? Same thing as 6 plus positive 1. That's 7. So we have b to the 7th. And then C, we have C to the negative 3rd over C to the 5th. When you divide like bases, you subtract those exponents. What's negative 3 minus 5? That's negative 8. So we end up getting 3, a to the negative 6, b to the 7th, c to the negative 8. Now to finish simplifying, anything with a negative exponent has to go to the other side of the fraction bar. So we're going to take a to the negative 6th and c to the negative 8th, move those to the denominator where they get positive exponents now. So we get 3b to the 7th over a to the 6th, c to the 8th. And you're done.
What type of elephant can fly? A propelephant? You try.
Okay, doing the same thing here. So we have 5 to the negative first over 5 to the negative seventh. When you divide like bases, you subtract the exponents. So what's negative 1 minus negative 7? Same thing as negative 1 plus positive 7, that's 6. So we get 5 to the 6th power. But you don't leave it like this because we're simplifying our expression. So what's 5 to the 6th? That's going to be 3,125. Here, d to the 14th over d to the 17th. When you divide like bases, you subtract the exponents. What's 14 minus 17? That's negative 3. So we end up getting d to the negative third. Again, since we're simplifying, we can't have a negative exponent in our answer. So we're going to take this d to the negative third, move it to the denominator, and make it 1 over d to the positive third, because when you move it, the exponent becomes positive. Here, b to the third times c to the negative fifth over b to the fourth times c to the negative first. Again, we're going to divide each of these variables separately and then multiply them together. So what's b to the third over b to the fourth? Well, again, since you're dividing like bases, you subtract the exponents. What's 3 minus 4? That's going to be negative 1. So we get b to the negative first, and then c to the negative fifth over c to the negative first. When you're dividing like bases, subtract those exponents. So negative 5 minus negative 1, same thing as negative 5 plus positive 1, that's negative 4. So we get b to the negative first, c to the negative fourth. Now, we can't have a negative exponent in our answer, so anything with a negative exponent, we move to the opposite side of the fraction bar to make it a positive exponent. So this becomes 1 over b to the first, or just b, times c to the fourth. Over here, the threes, we'll do with the threes first. So 3 to the second over 3 to the fifth. When you divide like bases, subtract those exponents. What's 2 minus 5? That gives you negative 3. So we get 3 to the negative third. Now with the x's, we have x to the fifth and just x. X is technically x to the first power. So what's 5 minus 1? That's going to be 4. So we get x to the fourth. Y to the negative eighth over y to the negative fourth. Subtract these two exponents and you end up getting negative 8 minus negative 4, or negative 8 plus positive 4. That's negative 4. And then z to the third over z to the third. What's 3 minus 3? That's 0. So you technically get z to the 0 power. Now, anything with a negative exponent, got to go to the denominator. So we take this 3 to the negative third and the y to the negative fourth, move it to the denominator where they get positive exponents now. And the z to the 0 turns into 1, right? Anything to the 0 power turns into 1. So it technically goes away because you're multiplying by 1. So your final answer looks something like this. Next, let's talk about raising a quotient to a power. So to raise a quotient to a power, you're going to raise the numerator and denominator to the power and simplify. So if you have a fraction all being raised to a power, some exponent, you just raise the numerator to that exponent and the denominator to that exponent. That's all you got to do. Super easy. So here, example 3, we want to simplify each expression. So we have this fraction being raised to the third power. So what we're going to do is we're going to raise the numerator to that power and the denominator to that power. Now, if you do x to the fourth raised to the third power, right, that's a power to a power. So you have to multiply those. So this becomes x to the 12th in our numerator, and our denominator becomes 3 to the third. Now, can you simplify this further? Yeah, what's 3 to the third? 3 times 3 is 9, times 3 is 27, and you're done. Here we have m over n, all being raised to the negative fifth power. Again, this exponent goes with our numerator and our denominator. Now, we can't have a negative exponent in our answer. In order to simplify this, what we have to do is take this m to the negative fifth, move it to the denominator where it gets a positive exponent, and then take this n to the negative fifth, move it to the numerator where the exponent becomes positive. So we get n to the fifth over m to the fifth, and you're done. Here, again, we raise the numerator to this power and the denominator to this power. So this in our numerator becomes 8 squared p squared. And in the denominator, we get 7 squared q to the 12th. Because if you're raising this whole thing to the second power, a power to a power, you have to multiply those. Now we just simplify. What's 8 squared? That's 64. What's 7 squared? That's 49. For part D, doing the same thing. Again, you're raising the whole numerator to this power and the whole denominator to this power. Now, again, when you raise the numerator to the negative fourth power, you need to raise 4 to the negative fourth and a squared to the negative fourth. So when you raise a squared to the negative fourth, it's power to a power, so you multiply those. That's how you get a to the negative eighth. Same thing down here. It becomes 5 to the negative fourth power, b to the, since it was 6 power, all being raised to the negative fourth, power to power, you multiply, that's how you get the negative 24th power. In order to simplify this, we can't have a negative exponent, so anything with a negative exponent has to move to the opposite side of the fraction bar in order to make the exponent positive. So the 4 to the negative fourth moves to the denominator, the 5 to the negative fourth moves to the numerator, the 8 to the negative eighth moves to the denominator, the b to the negative 24th moves to the numerator. Now we can simplify this a little bit further with our numbers here. 5 to the fourth ends up giving you 625, and 4 to the fourth gives you 256, and you're done.
How did the elephant get on top of the building? The elephant door! You try.
Again, raise the numerator to the third power and the denominator to the third power. So -3 squared, all raised to the third power. Power to a power, you multiply those, so you get -3 to the sixth power. In our denominator, power to a power, c to the fifth being raised to the third power, you multiply those, you get c to the 15th. Now, is there anything else we can simplify? Yeah, -3 to the sixth power, we can actually multiply that all out. -3 times itself 6 times is going to give you 729. Here, we're raising our numerator and denominator to the 0 power. Now, what you could know right away, shortcut, anything being raised to the 0 power equals 1. So you could just stop right there, or you could raise each particular part of this to the 0 power, but you still end up getting 1. For part C, we're doing the same thing. We need to raise the numerator to the 4th power and the denominator to the 4th power. So when you raise the numerator to the 4th power, it's going to be 6 to the 4th and w to the 4th. In our denominator, it's going to be 2 to the 4th, and it's going to be w. Since it's already to the 4th power, you have to multiply power to a power. You end up getting w to the 16th. Now, here, these are like bases. So what we can do, when you divide like bases, you subtract the exponents. What's 4 minus 16? That's going to be -12. So this right here, 6 to the 4th ends up becoming 1,296. 2 to the 4th becomes 16. And then we divided these, we ended up getting w to the -12. Now, this right here is actually going to simplify to 81. W to the -12th, right? We can't leave it with a negative exponent, so we move it to the denominator where the exponent becomes positive. So we get 81 over w to the 12th. And then for part D, we're raising the whole numerator to the -2nd and the whole denominator to the -2nd power. Now, since it's all multiplication, each part of this gets raised to the -2nd power. So this becomes 3 to the -2nd, x to the -2nd, y to the -10th, because power to a power, you have to multiply. Down here, this becomes x to the -8th, because it's power to a power, you got to multiply, and y to the -2nd. Now, anything with a negative exponent, you got to move to the other side. So this 3 to the -2nd, we can move down here. It becomes 3 to the +2nd. Now, before we move any of the x's or y's, we can actually simplify these, right? So since these are like bases, we just subtract the exponents because we're dividing. What's -2 minus -8? That's the same thing as -2 plus +8. So that would be 6. So this becomes x to the +6th power. And then y to the -10th divided by y to the -2nd. Since you're dividing like bases, you subtract the exponents. You end up getting y to the -8. So we get 3 to the -2nd, x to the 6, y to the -8. Now, as we said, to make negative exponents positive, we move it to the opposite side of the fraction bar. So this 3 to the -2nd goes to the denominator, where it becomes 3 to the +2nd, and y to the -8 goes to the denominator, where it becomes y to the +8, and you're done. Now, dividing numbers in scientific notation. So to divide two numbers in scientific notation, divide the two numbers in front and subtract the exponents of each 10. So here, if you're dividing a times 10 to the nth power and b times 10 to the m power, you just divide the a and the b and then subtract the n and the m. That's how you simplify this. What's going to happen likely is that a divided by b will give you a number not between 1 and 10 anymore. So then you have to simplify like we have been doing. Example 4 says simplify each expression. So here, again, we said when you divide two numbers in scientific notation, divide the two numbers in front, subtract the exponents of the 10. So 6 divided by 2 is going to give you 3, and then 8 minus 2 is going to give you 6. So we get 3 times 10 to the 6th power. Part B, again, divide the two numbers in front, subtract the exponents of the 10. So we're going to divide these two numbers, 3.6 and 9. You end up getting 0.4. And then -10 minus -8 is the same thing as -10 plus +8, so that's -2. Now to simplify this, right, we need to make sure that it's in scientific notation. So this 0.4 is not between 1 and 10. We have to make it between 1 and 10. So we move our decimal point one place to the right, which means we have to subtract 1 from our exponent here, and we end up getting 4 times 10 to the -3rd power. Part C, divide the two numbers in front, subtract the exponents. So when we subtract these two exponents, what's 8 minus 17? That's going to be -9. And when we divide these two numbers in front, we end up getting 1.3. So we get 1.3 times 10 to the -9. Because this number in front is between 1 and 10, we're done. We're good. Part D, divide these two numbers in front, subtract these two exponents. So what's -5 minus 2? That's -7. And when you divide these two numbers in front, what do you get? 1.5. Well, because this number is between 1 and 10, you don't have to simplify any further. You're good.
Why did the elephant like visiting the redwood forest? 'Cause of all the big trunks. You try.
Okay, again, to divide two numbers in scientific notation, divide the numbers in front, subtract the exponents. So what's 9 divided by 4.5? That's going to be 2. And then what's 7 minus 8? That's going to be -1. So we end up getting 2 times 10 to the negative first power. Here, divide the two numbers in front, subtract the exponents. So what's -5 minus -16? That's going to be the same thing as -5 plus +16. So that's 11. So it's going to be 10 to the 11th power. And what's 2.5 divided by 8? That's going to be 0.3125. Now, what you're going to have to do here, this number is no longer between 1 and 10. So you have to convert it so it is. So we're going to move the decimal one place to the right. Now, when you do that, since you move one decimal place to the right, you have to subtract 1 from your exponent here. So that ends up giving you 3.125 times 10 to the 10th power. Down here, divide the numbers in front, subtract the exponents. What's -5 minus -8? That's going to be the same thing as -5 plus +8, so that's 3. And then 8.4 divided by 2 is just going to give you 4.2. So we end up getting 4.2 times 10 to the 3rd. Lastly, 3.5 times 10 to the 6 over 5 times 10 to the 8th. Divide the numbers in front, subtract the exponents. So here, our exponent 6 minus 8, that's going to give you -2. And then 3.5 divided by 5 is going to give you 0.7. So we get 0.7 times 10 to the negative second. This number is no longer between 1 and 10, so we have to move it one decimal place to the right, which means we subtract 1 from our exponent, and we end up getting 7 times 10 to the negative 3rd power. Now our word problem says the wavelength of a radio wave is defined as speed divided by frequency. An FM radio station has a frequency of 9 times 10 to the 7th waves per second. The speed of the waves is about 3 times 10 to the 8th meters per second. What is the wavelength of the station? So step 1 in a word problem. We're not scared. We can do this. Step 2, define our variables. What is this question asking us to find? It wants us to find the wavelength of the station, right? So we'll say W is the wavelength of the station. Anything else that we have to provide variables for here? Well, it says the wavelength of the radio wave is defined by speed divided by frequency. Speed divided by frequency, we obviously need to make speed and frequency a variable too. So S is the speed of the radio wave, F is the frequency. So now, we got our variables. Let's write our equation. What's our equation? Well, it says wavelength of our radio wave is defined as speed divided by frequency. So wavelength equals speed divided by frequency. So now, what do we plug in? Is there anything we can plug in for stuff? Well, it says an FM radio station has a frequency of 9 times 10 to the 7th power. So that we're going to plug in for F. And then it says the speed of the waves is about 3 times 10 to the 8th meters per second. So 3 times 10 to the 8th, we're going to plug in for speed. So it looks something like this. Now we can simplify. How do we divide two numbers in scientific notation? We divide the numbers in front, subtract the exponents. So what's 8 minus 7? That's going to be 1. And then what's 3 divided by 9? That's going to be 0.3 repeating. We end up getting 0.3 repeating times 10 to the first. This number in front is not between, it's not between 1 and 10. So in order to put it between 1 and 10, make it in scientific notation, we move the decimal one place to the right, which means we subtract 1 from our exponent, and we end up getting 3.3 repeating times 10 to the 0, right? Which is just 3.3 repeating, because 10 to the 0 is technically 1. That means that the wavelength of the FM radio station is about 3.3 or 3 1/3 meters. And you're done.